The objectives for this week are to find the indicated terms of an arithmetic sequence and then find the sums of an arithmetic series. Now, we talked about sequences and series last week. This week, we're going to focus in on arithmetic sequences and arithmetic series. And then next week, we're going to do the same thing, but we're going to talk about geometric, so geometric sequences and geometric series. Recall that linear functions have a constant first difference. Notice also that when you graph the ordered pairs n, a sub n of an arithmetic sequence, the points lie in a straight line. Thus, you can think of an arithmetic sequence as a linear function with sequential natural numbers as the domain. Each term in an arithmetic sequence is a sum of the previous term and the common difference. This gives us the recursive rule a sub n is equal to a sub n minus 1 plus d. You also can develop an explicit rule for an arithmetic sequence also. And tonight you're going to have to be able to do that. So let's give an arithmetic sequence. Okay, so 5, 7, 9, 11, 13, dot, 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 dot. This is an arithmetic sequence. Why is it so? Because every term is going up or down by the exact same thing. We're adding or subtracting the same number, and it's 2. So in order to write a recursive formula for this, I would just say a sub 1 is equal to 5, and then my recursive formula, a sub n, would equal a sub n minus 1 plus 2. I'm just adding 2 each time. Now, if I want to write a explicit rule, which is more common, writing explicit rules, all you need to know is the d value and a sub 1. So the d value in this problem is 2. A sub 1 is 5. So the formula for an explicit would be a sub n is equal to a sub 1 plus d n minus 1. Now, I never let students leave the parentheses in here. So if I plug in my values here, a sub n is equal to 5 plus 2 n minus 1. Okay, so now I'm going to multiply this through. So that gives me a sub n is equal to 5 plus 2n minus 2. And my final formula, since I put the 5 and the negative 2 together, 2n plus 3. Now, you can check it yourself really quick. We know the first term is 5, so if I put 1 in here, 2 times 1 is 2, plus 3 is 5. Oh, that works. I know the third term is 9, so if I put 3 in here, I should get 9. 2 times 3 is 6, plus 3 is 9. Ah, it works. So we should be able to write a recursive rule and an explicit rule for arithmetic sequences. Determine whether the sequence could be arithmetic. If so, find the common difference. All right, so negative 10, negative 4, 6, 8, 14. It looks like it's going up by 6 all the time, doesn't it? So this is an arithmetic sequence, and the common difference is 6. Here I go from negative 2 to 5, negative 5 to 11, negative 11 to 20. That does not seem like it's going by the same thing. So negative 2 to negative 5, that's negative 3. Negative 5 to negative 11, that looks like negative 6. Negative 11 to negative 20, that looks like negative 9. This definitely is not an arithmetic sequence. And we won't be dealing with those tonight or this week. Find the common difference, d, of the arithmetic sequence. 4 to 6, 6 to 8, 8, d is equal to 2. Find the common difference of the arithmetic sequence. 3, 5, 7, 9. Looks like 2 also. The general rule for an arithmetic sequence, if you're writing it, and we did this already, I don't know why they put the d behind, I always put the d in front. So if you're dealing with an explicit rule, a sub n is equal to a sub 1 plus your difference, n minus 1. So all you really need is you need the first term and you need the common difference. And then you can write an arithmetic sequence for, or a general rule for that sequence. So let's find the 12th term here. Well, I don't want to write out all 12 terms, so I'm just going to write a rule. So 20 to 14, 14 to 8, 8 to 2, 2 to 4. That does not even look arithmetic, does it? 20 to 14, that's 6. 14 to, oh yeah, maybe, no, because 2 to 4 is definitely not 6. I don't think that's right. I think that must be a -4, to tell you the truth. Because then, well, it's really subtracting 6. We're always going down by 6. Okay, so I'm gonna make this a -4, because then it would be an arithmetic sequence. Without that negative there, it's definitely not an arithmetic sequence. Okay, so my d value is -6. My first term is 20. So if I'm going to write an equation, a sub n is equal to a sub 1 plus d n minus 1. So a sub 1 is 20 plus -6 n minus 1. I'm going to multiply through here. So that gives me -6n plus 6. So my equation is a sub n is equal to -6n plus 26. Now, if I want the 12th term, all I do is I plug 12 in here. Now, let's check and see if it works. I know the first term was 20, so I put 1 in here. -6 times 1 is -6 plus 26. Oh, that gives me 20. So, yeah, just plug 12 in there, and you would get the 12th term there. Find the 11th term of the arithmetic sequence. I wish they would have just asked, write the explicit rule here. So let's write an explicit rule. Okay. Looks like I'm going down again. Looks like it's going down by -2 here. So a sub 1 is equal to -3. D is equal to -2. So my formula, again, a sub n is equal to the first term plus the d n minus 1. So that gives me -3 plus -2 n minus 1. So that's -2n plus 2. So that's -2n minus 1. Now, does it work? Well, my first term, if I put 1 in here, -2 times 1 is -2 minus 1, gives me -3. So my first term is -3. So it does work. And then all you have to do is plug in 11. So -22 minus 1. So the 11th term should be -23. Because arithmetic sequences have a common difference, you can use any two terms to find the difference. So for example, if they told us a sub 2 is -133 and a sub 3 is -121, all we have to do is figure out the difference between them, and that gives us our d value. So it says find the 90th term of the arithmetic sequence. Now there is no way I am going to figure out, make the 90th, try to come up with the 90th term. So the thing I'm going to do is I'm just going to figure out the formula and plug 90 in for my value. Okay, so let's see here. So let's 13.6 minus 8.9. It's going to give me my d value, which is 4.7. So my d value is 4.7. My a1, my first term, is 8.9. So my formula, a sub n is equal to 8.9 plus 4.7 n minus 1. So this is going to be 4.7n minus 4.7, 4.7. So a sub n is equal to 4.7n, and then 8.9, looks like this is 4.2. Okay. So now if I wanted to come up with the 90th term, I just put 90 in here. So I'll get my trusty calculator out because there's no way I'm going to multiply this out. 4.7 times 90 plus 4.2 is equal to 427.2. Find the fifth term of the arithmetic sequence. Now, in this one, I'm not writing out an explicit formula because the fifth term is pretty easy to come by. It's just the next term. So it looks like it's going up by 4, up by 4, up by 4, 19. Woof. That one was way too easy. An arithmetic series is the indicated sum of the terms of an arithmetic sequence. You can derive a general formula for the sum of an arithmetic series by writing the series in forward and reverse order and adding the results. Now, let's just give you the formula. The formula for an arithmetic sequence is right here. S of n, the sum of the number of terms, is equal to n, which is the total number of values that you're adding together, a sub 1 plus, so the first term plus the last term, divide by 2. Okay, so let's see if this works. Let's do an arithmetic sequence. Let's do a real easy one. 1, 3, 5, 7, 9. So we'll just do, so 1, 2, 3, 4, 5. So let's find S of 5 of this formula. Well, we already know the first term and the last term because we can see them. We know what n is, it's 5, so this is 5. And then the first term is 1, the last term is 9, divide by 2. So that's 10 divided by 2, which is 5. So 5 times 5 is 25. So S of 5 is equal to 25, using our formula. Now let's just add it up. 1 plus 3 is 4, plus 5 is 9, plus 7 is 16, plus 9 is 25. So that does work. So this formula right here gives us the sum of an arithmetic sequence. So we need to know n, we need to know the first term, the last term, divide by 2. Pretty easy formula. So here it says find the indicated sum for the arithmetic series. S of 18. Oh no, we don't know the last term. We don't know the 18th term here. Okay, so now it's going to take a little bit of work. So I know n is equal to 18 here. I know a sub 1 is equal to 13. I don't know what a sub 18 is. So I can set up my formula. So this is going to be 18, 13 plus, I don't know what that is, divide by 2. All right, so I need to find the 18th term. How am I going to do that? Well, guess what? I'm going to set up an equation. Okay, so this looks like it goes down by 11, down by 11. So I've got my d value is negative 11. My a sub 1 is equal to 13. So to come up with my formula, I'm just going to use 13 plus negative 11 n minus 1. So that's 13 plus negative 11n plus 11. It's negative 11n plus 24. Okay, so that should give me any term. So if I want to find the 18th term, I just plug 18 in here, plug that value in there, and work it out. That's all there's to it. It's fairly simple to do. It shouldn't cause too many problems.